Hi friends, and a very warm welcome to all of you in this e-learning session. Harsham welcomes you over here. We are doing which lesson? I hope you remember we are doing chapter number 3, that is gravitation. In today's lecture, we are going to take on few very small topics of the lesson. Okay? Which are the small topics? Let's have a look. The very first one is the centripetal force. Very first one is this, which is centripetal force. Now what is this centripetal force? Assume that the object is moving on a circular path. The object is constantly moving on a circular path. It is going on moving, going on moving, going on moving and going on moving. Because it's moving on a circular path, the center is attracting it towards itself. The center attracts the object towards itself, and that is called as centripetal force. So what is centripetal force? It is the force which attracts the object towards the center. The formula for the centripetal force is F is equal to mv square upon r. What is the formula for centripetal force? It is this. F is equal to mv square by r. What is the formula for centripetal force? F is equal to mv square by r. This is the formula of anything that is getting attracted towards the center, where m is the mass of the object, v is its velocity with which it is moving, and r is the radius of the circle. So this is what? It is a circular motion where what is the direction? The direction will be in the direction of tangent. The direction of the object will be in the direction of its tangent. Like we did in motion chapter last part, uniform circular motion, somewhat something like that. But always remember that whenever any object is moving around us in a circular path, always it gets attracted by center. Okay, that is called as centripetal force, and its formula is F is equal to mv square by r. Kindly note this point. After that we will do the significance of gravitational law. In today's lecture we are going to see all the small concepts that we have not discussed yet. Be quick, I am giving you 2 minutes time. 1 minute time, it's enough. 1 minute is enough to note this. All the small topics we'll cover up today. Be quick. And remember the topic that we are doing. We did centripetal force. Because today we are going to cover a more number of topics. All the small topics will be covered up today. I hope you have noted this. Then next is significance of gravitational law. What is the gravitational law? Do you remember what is the gravitational law? The gravitational law is the force that is existing between two objects is directly proportional to product of the mass and inversely proportional to the square of the distance between them. What is the direction? The direction is along the centers that is joining the line. Okay, it is in the line that is joining the centers. Now let's have a look at what is the use of this gravitational law. One by one we will see all. is the significance of gravitational law? The very first thing that you know that planets are moving around the sun because of its gravitational force. We know that planets are moving around the sun because of the gravitational pull of the sun. Okay? Mercury, Venus, Earth, Jupiter, all. Mars, Saturn, Neptune, Pluto, all are moving around the sun. Why? Because of the high gravitational pull of sun. And sun is so big that it occupies about 99% volume of whole of our solar system. Such a giant object. So, its gravitational pull is going to be very high. And hence, it is able to fetch all the objects towards itself. It is able to fetch all the planets towards itself. And hence, all the planets are moving around the sun. And they are moving around the sun in an elliptical orbit. Okay? So planets are moving around the sun because of gravitational force of sun. Next, atmosphere exists because of gravitational pull. Now, what is actually this and how is this concerned with? We are knowing that the atmosphere is made up of various different gases, right? We know or not? Yes, you already know that atmosphere is containing nitrogen, oxygen, then other gases, carbon dioxide, helium, argon in very small proportion although. But yes, these gases are existing. So, how can these gases stay on the earth? Why they are not floating away in the sky? Okay, oxygen is ultimately a gas. Why it is staying on the earth? Why it is not going and roaming anywhere in the universe? The only reason of it is the gravity of the earth. The gravity of the earth is pulling all the gases towards itself. Because the gravity of the earth is pulling all the gases towards itself, the atmosphere is remaining confined. Okay, atmosphere is remaining confined over there. So this is how the atmosphere is existing because of gravitational pull. Now next, tides in the ocean. From the day you are studying about the moon, you are knowing that moon is the satellite, a natural satellite, which is responsible for the tides that are occurring in the ocean. Now, actually what is happening? Let's have a look. This is our Dada, Sun Dada. Then, here is Earth. And around the Earth, what is moving is Moon. Right? This is the whole situation. Now, Earth is moving. It is revolving as well as it is rotating. And the Moon is revolving around the Earth. Now, because the Earth is rotating also, because of that, the gravity of the Moon and the gravity of the Earth, these are the two gravities that are existing. Okay, Moon is having less mass as compared to Earth, but although it is having its own gravity, because of the Moon's gravity, it is trying to pull everything of Earth towards itself, while Earth is trying to pull everything of Moon towards itself. That is the gravitational force. And because Earth is made up of 75% of water, this water gets affected by the gravity of Moon. This water gets affected by the gravity of moon, and hence the tides are there in the ocean. Getting what a ma'am is saying? I hope that you are understanding what I am trying to say. Tides, why are they occurring in the ocean? That is because of gravitational pull of moon. So this is what is the reason. Next, the artificial satellites. Are gathering all information because they can move around Earth due to its gravitational force. Whatever are the artificial satellites, whichever we are sending from here, from the surface of the Earth in the space, they are moving around the Earth. Why are they able to move around the Earth? They are able to move around the Earth because of the gravitational force of the Earth. And hence they are able to do that particular job for which they are just being sent. I think all of you might have seen the movie Mission Mangal. Okay, there you might have seen how from the Earth's gravity they are trying to see that the particular satellite, it leaves the Earth's gravity and it goes into the gravity of Mars. So that is what is actually really happening. Okay, in order, whatever is the satellite being launched, if it is getting launched with some particular some particular speed we are launching it, then it will stay around the Earth because of the gravity of the Earth. It will rotate around the Earth because of its gravity. And so only it is able to gather all the information. Whatever information we are getting through the artificial satellites, it is what? A boon of the Earth's gravity. Okay, it is able to scan each and every part. In many movies you might have seen that because of the artificial intelligence they came to know about this particular weapon or like that. Try to recall, you might have seen many such movies. So, what you have to take from the movie is this: how is artificial satellite useful? It's Earth's gravity that is allowing. The last one is we are able to maintain ourselves on Earth. That means we are not floating because of Earth's gravity. Precipitation is occurring because of Earth's gravity. Okay, it's not happening that we all are like flowing in the sky like you might have seen many such videos where you might have seen the astronauts, how are they floating in the chamber. That's not happening with us. Why? Because Earth's gravity is keeping us the hold. We are not floating in the sky, nor even on the surface of the Earth because of the Earth's gravity. Another boon of gravity is precipitation. You all are knowing that because of evaporation the clouds are formed, but that clouds are ultimately falling on the surface of the Earth because of precipitation. And why is the precipitation occurring? It's because of Earth's gravity. So gravity is a boon for us. The gravity is helpful to us in these ways. Okay, so please note it down quick. This is not in detail as given in your book. These are the short ones, short and sweet ones. I'm giving you 1 minute time to note it. After that, we'll study how the gravity is associated with what is the law of gravitation. We have already seen. We'll talk about the small g now. Okay, be quick. Quickly note it. The topic we are doing is this, that is significance of gravitational law. Be quick in noting. Now let's move further. Now we are going to derive the formula for small g. How will we derive now? We are knowing as per Newton's law of motion. Newton's second law, force is equal to product of mass and acceleration. We have started this in chapter number 2. That is F is equals to ma, right? Haven't we studied? So you are having F is equals to m into a. Now over here, when we are talking about the gravitational acceleration for any object of mass m, the force and if the another object, if we talk about it is getting pulled by the Earth's gravity, then the force existing will be mass of that object multiplied by the gravitational force of the Earth. We are talking about the Earth, and on that Earth we are having an object, small object of mass m. Okay, so what is the force with which the gravity of the Earth is pulling it towards itself? F is equals to mg. As per gravitational law, if I talk about the gravitational law, then what will be the force that is getting exerted between these two particular objects? As per the gravitational law, the force will be F is equals to gm1 m2 by r square. This is small m, this is capital M, r suppose the radius of the Earth. So what will be the force equals to? F is equals to g small m into capital M upon r square, where what is m? Here m is mass of the object, capital M is the mass of the Earth, r is the radius of the Earth, and this small m is the mass of the object. Okay? Now both of these are force. So on comparing both the formulas, comparing 1 and 2, what do we get? M into G is equals to GMM by R square. Right? F is equals to GMM by R square. Now what will happen? This small m will get cancelled now. So you have small g as capital G into mass of that particular, over here, earth. We are talking about the earth upon the radius of the earth square. So this is about the formula of gravity of earth, the gravitational acceleration of the earth. Okay? Small g, that is gravitational acceleration of the earth, is gme by re square. I am going to deduce many things with respect to this. What things I am going to deduce over here? When we put the mass of the earth over here, the radius of the earth over here, once we put this value over here, 6 into 10 raised to something, and here again 6.0 into 10 raised to something. Value of capital G is 6.673 into 10 raised to minus 11. Once you put all this value, you get the value of GE as 9.8 meter per second square. And that's what? That's the gravity with what the earth is pulling everything. Okay? I'm going to explain you that mathematically. First note this, and for noting this, I'm giving you 1 minute time. Quickly note this much, then we will discuss on this. GME by RE square. This is this formula derivation. Be quick, note it. After that, I'll explain you how small g is 9.8. Be quick. Be quick. Assume that you have written. Now we are going to move further with this particular formula. GME by RE square. What is the formula? G is equals to GM by R square. If we talk about the gravity of any particular planet, then for any planet it will be Gp is equals to mass of that planet upon radius of that planet. That means that gravitational acceleration of any particular object is independent of the mass of falling object. This was discussed in free fall. When the free fall was being done at that time, small g, it was explained as it is independent of mass of falling object. I hope you are getting what ma'am is trying to explain. So gravitational acceleration of any particular planet is like this. This is the key point that you have to note. If we talk about Earth, let's put the value of Earth. Mass of the Earth is this much. Radius is this much. Once you solve all this, you get the gravitational acceleration of the Earth as 9.8 meter per second square. It's not exactly 9.8, it's 9.7 something. But for our convenience, what do we take? 9.8. Okay? Note this quickly. And you have to try out this calculation at your home. Now we'll discuss about how the gravity is varying at particular height and at particular depth within the surface of the earth and above the surface of the earth. Be quick, 1 minute time for you to note this. After that we'll study how the gravity is varying. Assuming that you have noted it, let's move further. Now what we are going to do, we are going to see how the gravity of the earth is varying. Gravitational acceleration. The variation in the gravitational acceleration. From your lower standards, you are studying that Earth is not a perfect sphere. It's like an orange. You are studying this point, right? Earth is not a sphere, it's like an orange. Not totally oval, but little bit like an orange, like this. Yes. So, you all are knowing that it is little bit compressed from its top. So, if we talk about the radius, over here you are having equator and here you have pole. The North Pole and the South Pole. Above you have North Pole, below you have South Pole. So you are having two poles. So this is polar radius and this is equatorial radius. Because the earth is like an orange, this is polar and this is equatorial radius, I can say that the polar radius is less than the equatorial radius. Equatorial radius is more as compared to polar radius. Moreover, from this equation, you can say that G is proportional as G is proportional to 1 by r square. This is what we know, that gravitational acceleration is inversely proportional to the square of the radius. Less the radius, more the gravity, because it is inversely proportional. So gravity at pole is more than gravity at earth. Equator. The gravity at pole will be more than the gravity at earth or equator. Why? On the earth, at poles, on only one earth, where in one planet only we are talking about. There also G, small g is varying. Why it is varying, and that we are discussing. The gravitational acceleration at poles is more than the gravitational acceleration at equator. What's the reason? The reason is this. The polar radius is less than the equatorial radius. Okay, I hope you are getting what I am trying to say. Next, we are going to discuss from here about two things. One is about the gravity at height. Another is about the gravity at depth. How can we find out the gravity at height? Suppose there is a particular object which is at height h from the surface of the earth, and this height is very much. This much is the radius of the earth. I want to find out the gravity over here at height h. Then at height h, the gravitational acceleration is small g is capital G into mass of the earth upon radius of the earth plus height h the whole square. If it is very near to the surface of the earth, we can neglect this height because the radius of the earth is 6 into 10 raised to 6.04 into 10 raised to 6. If the height is small, then we neglect this h and it becomes gm by r square. But if it is at height h, this is the formula. So gravity at height, that is also changing, as in how the person is going up, the gravity is reducing because that radius is going on increasing. So the gravity reduces. And that's why people float in the sky. Okay? Next, the gravity at depth. Assume that is a particular object which is at depth d inside the surface of the earth. We are talking about going below, inside the earth. So over here, the gravity at depth is given by the formula as gravity at surface 1 minus d by r. What is the d? The depth. While what is the r? The radius of the earth. This much is r. So if you are going inside the earth, then also gravity changes. Outside the earth, above the earth, then also gravity changes. On the edges and on the top bottom, then also gravity changes, because earth is not a sphere. Okay? And the gravity is depending totally upon the radius. Less the radius, more the gravity. More the radius, less the gravity. And this is how it is depending. The derivation of this particular fact, that is the gravity at depth is equals to gravity of surface into 1 minus d by r. This particular derivation is coming in class 11. If you are interested in doing it, just say me, I will do it just for you. Okay, after watching today's lecture, if you feel that you want to do this topic, I'll teach you personally. Okay, through a WhatsApp call or anything, whatever. But I'll definitely teach you this particular concept if you are interested in doing. That's the first criteria. This is the variation in the gravitational acceleration. So please note it down. After that, we'll discuss a very small topic, the difference between the two terms, mass and weight, which people feel to be same, but it's not the same. So these are the topics that we have done, and the last topic that we are going to do is the difference between the mass and the weight. After doing this particular concept of mass and weight, we'll complete on with the theory of chapter number 3, that is gravitation. Be quick in noting it. You have exactly 1 minute to note it. Be quick. Then we'll move further. Now let's move further. The next particular concept is mass and weight. These two terms appear to be same, but they are not same. These two terms are different from each other. Very first thing is, mass is a scalar quantity. What actually mass is? Mass is quantity of matter. Okay, while weight, it is mass multiplied by the gravitational acceleration. That is the definition. What is mass? It's quantity of matter. While what is the weight? Weight is the product of mass and gravitational acceleration. So whenever you are multiplying the mass with the gravitational acceleration, what do you get? You get weight. Generally we use both of these things as same, but these two things are not the same. This is a word of caution. Be careful over here. Mass and weight, although we are in our day-to-day routine, we speak it as same, but they are different. Let's have a look at it. So what is the mass? It's the quantity of matter. Well, what is the weight? Weight is the product of mass and gravitational acceleration. Mass is a scalar quantity. Mass is a scalar quantity, while weight is a vector quantity. Next, mass is constant everywhere. While weight depends on the gravitational acceleration at that particular point. Because you are getting g over here, one acceleration, so vector quantity. So this will become a vector quantity. While weight, it depends on g. Where the g is less, what happens? People feel like weightlessness when they are going in the space. There is no gravity. No gravity, so how is the feeling? They just feel that they are floating. Sunita Williams, when she returned back after a long journey, when she was stuck up in the space, when she came back, she was just saying that, I'm not able to realize that really I'm on the earth. Because it's very tough to put the foot on the earth when you are after floating. So that is the weightlessness thing. You feel that you have no weight. But because the weight depends on the gravitational acceleration. Mass can never be zero. Weight, it can be zero. Next, mass is measured using beam balance. Weight is measured using spring balance. Mass is measured using beam balance. Weight is measured using spring balance. Next, the SI unit of mass is kilogram, while of weight, its SI unit for weight is Newton. Okay? This is how the mass and weight differ from each other. Note this, be quick in noting. You have exactly 1 minute to note it. This is easy one, and moreover, this difference is also given in your book. But some of the points, the first definition itself is not given. So, noted it, that's more good. If not noted, take the screenshot so that I can move further. Okay. I hope that you have understood today's content. What was done today? Centripetal force F is equal to mv square by r. Significance of the gravitational law. We saw how the gravity of the earth is helpful to us in various ways. Then we derived the value of small g, that is capital G m by r square. The gravity of the earth, that is 9.8 meter per second square. The variation in the g at height, at depth, and even on the surface of the earth, because the polar radius and the equatorial radius are different from each other. Last, we discussed about the difference between mass and weight. So here we complete with the theory of chapter 3, gravitation. In the next particular session, we will see the numericals of this particular chapter. For kind information, the numericals of this chapter are very interesting. Why? Because they are dealing with some of your basic concepts of mathematics. If you know the power and indices properly, you will be able to solve all the numericals very easily. The calculations are a bit tough, but the concepts of this particular numericals are very, very easy. That's all for the content of the day. I hope that you have understood the today's content well. That's all. Thank you all everyone for listening to me, and have a very good day. Bye-bye all of you.